3, 2, 1.
The revelations about New Horizons' visit to Pluto last week made headline news.
Scientists have tonight been celebrating the arrival of detailed images of Pluto.
Here at the Sky at Night, we've been lucky enough to be behind the scenes, following the unfolding story every step of the way.
We've recorded data of the Pluto system, and we're outbound for Pluto.
Revealing the in-depth science behind the incredible images of Pluto and the surprising discoveries of mountains and strange geometry on the surface of this cold and distant world.
It's a fittingly stunning mission for our 750th episode. This is Mission Control at the Johns Hopkins University. For the past week, the world has been amazed by fabulous images of Pluto, beamed back from across the solar system.
It has been an astonishing week. When we got here, some people feared that Pluto would turn out to be a frozen and dead world, but we've watched as it turned into anything but. Until recently, Pluto was just an indistinct speck of light at the far edge of the solar system. As recently as April this year, this was our best image of Pluto and its moon Charon. But now, New Horizons has changed all of that.
This week's findings have transformed our understanding of the solar system, throwing up into the air our ideas of what causes changes to planetary surfaces. How can such a tiny world have such incredibly varied terrain, of mountains and plains? What are the different patches of colour across its surface? And do we need to rethink its relationship with its huge moon, Charon?
We'll also be showing you how to find Pluto in the night sky for yourself, examining why some no longer consider it a planet, and looking at where New Horizons is headed next. It all began last Monday, here at the Applied Physics Laboratory in Maryland. With just 24 hours to go before New Horizons reached Pluto, the flight controllers were in lockdown, while they nervously kept track of their spacecraft.
Copy that, RF nominal.
Outside, the world's media was gathering to see the revelations that New Horizons would make.
The first scientific details were already emerging. While the spacecraft was still millions of kilometers away, it has started sending back increasingly rich pictures. And now scientists like Carly Howitt, one of the core members of the imaging team, were nervously waiting to see what other surprises would emerge. When you get the first images after the flyby, what's the first thing that you look for on the surface?
Anything that's indicating that Pluto is still active. After that, it's going to be just what's going on, like how's the colour changing, how cratered is it, and so those are going to be things that I'm really excited to see. I got married last year, and it feels like the same thing, like you've done all this planning, and all of a sudden the days here kind of make sure you remember each and every moment rather than just it all being a whirlwind.
Let's hope we see some of those things.
Yes,
We will. Good luck.
Thanks very much. Yes.
For Carly, and many here, like Mission Controller Alice Bowman, this week was a critical moment after decades of preparation. A very long journey that has taken us right across the solar system.
We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
It's been almost a decade since New Horizons rocketed out of our atmosphere. For the team who built it, years of work were now hurtling towards Pluto, a 3 billion mile journey away. Heading out beyond Mars and through the asteroid belt, in 2007 New Horizons passed Jupiter. It was using the gas giant as a gravitational slingshot, increasing its speed and cutting 3 years from its journey time. But for Mission Operations Manager Alice Bowman, it offered a perfect test for her spacecraft.
Jupiter was extremely important for the mission. All of our instruments were brand new to space, And so we were using Jupiter as really an opportunity to test out these instruments for really the first time in observing a real object.
While it was passing, the spacecraft trained its cameras on the moon Io.
We were at the right place at the right time. We got notice from the Hubble Space Telescope that they had detected something going on.
This snapshot is from the color imager Ralph. It's undeniably beautiful, but it's the black and white lorry camera that captured the real detail. The camera caught a huge eruption 200 miles high, coming from the volcano Tavashta.
To see those images come back, all that hard work, all those long nights, come back with the spectacular images, it was great.
8 years ago, the spacecraft left the Jupiter system behind, crossing the orbits of Saturn, Uranus, and Neptune. It was now hurtling through the void towards Pluto, an object that's always been a bit of a mystery to us. Before New Horizons came along, we had to figure out everything about Pluto from a distance of 3 billion miles, and this is the best image that we had. And trying to find detail here is like trying to make out the writing on this coin from 13 miles away. This blurry, grainy image is what Pluto looks like to the Hubble Space Telescope, and we've had to put up with it. Despite the likes of the Voyager probes touring the solar system, Pluto has just never been in the right place for them to visit. Before its encounter with the dwarf planet, I caught up with Alan Stern, the principal investigator for the New Horizons mission. For him, the flyby is the culmination of decades of work.
This mission is running the anchor leg in a 50-year sequence of missions in which the United States has explored the entire solar system, from the closest planets, Venus and Mars, all the way out now to the farthest frontier.
So seen from here, from Earth, Pluto's just a speck, but what do we know about it already?
With Earth-based techniques and the Hubble Space Telescope, we've been able to learn a bit. So we know it's a fascinating world. It's a planet with 5 satellites, it has an atmosphere, it has seasons, we've discovered a polar cap, there are big surface markings.
Scientists were able to combine multiple Hubble observations to produce our first maps of Pluto. They revealed a world with dark and with light patches, a first hint of the surprises that awaited on Pluto's surface. We also suspected that the surface would be unlike anything we'd seen before, with temperatures as low as minus 233 degrees Celsius.
We know that the surface is primarily made of nitrogen ice, snows of nitrogen. We don't know how deep they are, but we also know that there's carbon monoxide snow, that there's methane snow, and there may be vast expanses of water ice as well.
But nobody knew how those strange snows and ices are distributed across the surface. What structures or surface features might they form? And what, if anything, could be going on inside this icy world? So if you could discover anything, if you could order anything from Pluto, what would you choose?
I would order something wonderful, something that we don't expect. You know, that's been the history of planetary exploration. The first mission to Mars found craters, and then they found river valleys, and no one expected either. And the first missions to the giant planets, to Jupiter, found volcanoes on Io and an ocean at Europa. And it's been our history in planetary exploration that we typically find completely unexpected richness in nature. And I'm hoping that Pluto presents us with something similarly wonderful that we're all talking about after the encounter.
While we were waiting for New Horizons to cross the final few 100,000 miles to Pluto, I went to investigate the suite of instruments the spacecraft was carrying. If you're going to send a spacecraft 3 billion miles into space, what sort of spacecraft do you build? Well, this is a 1/4 scale model of the New Horizons spacecraft. So the size has been described as about a baby grand piano, and you can see that from the shape here. How do you power such a spacecraft? Well, you're so far away from the sun, you can't use solar panels. There's not enough sunlight reaching them. So instead they use this. This is a nuclear device. It contains plutonium oxide. As the plutonium dioxide decays, it produces enough heat to generate 200 watts of electricity. This powers and heats the spacecraft instruments. While the temperature outside is below minus 200 degrees Celsius, The inside of the craft sits comfortably at room temperature. Down here, we've got a very important instrument. This is LORRI. It's the navigation and high-resolution camera. The wonderful images we've seen on the approach to Pluto have all been taken by LORRI. But LORRI is a black and white camera. Extra colour information is provided by Ralph that images in the visible and the infrared. The other instruments include ALICE, a UV spectrometer, 3 particle detectors, SDC, PEPSI, and SWAP. But the most prominent feature is this dish. Now, this is a dual-purpose dish. While the instrument's actually gathering data, the radio dish is actually turned away from Earth. To send information back, they have to spin the spacecraft towards Earth. This means that when it's getting data, the dish is actually pointing away from Earth, so we can get data or we can send data back. But we can't actually do both at the same time. That's why, at the critical stage of the Pluto encounter, the mission controllers won't have any contact with the spacecraft.
But New Horizons also carries one other important element. Tucked away inside is 1 ounce of the ashes of Clyde Tombaugh. The first human to visit Pluto is the man who discovered it back in 1930, one of the heroes of modern astronomy.
I had no idea that 2 little tiny black specks on some glass plates would cause this much of a rumpus.
Ladies and gentlemen, Dr. Tombaugh. This is Clyde Tombaugh talking in 1980. He was being honoured for his discovery of Pluto, and the Sky at Night was lucky enough to be able to interview him.
I first heard of the discovery of Pluto when I was a boy. What sparked off your first interest in astronomy?
Well, I had a very keen interest in geography, and then one day in grade school, the thought occurred to me, I wonder what the geography would be like on other planets.
Tombaugh quickly developed an interest in astronomy, even building his own telescopes. In fact, he was so good at it that when he sent pictures to professional astronomers at Flagstaff in Arizona, they offered him a job straight away. He was just 23 and hadn't even gone to college. As it happened, this job was at the Lowell Observatory, where they were hunting for a mysterious planet predicted to be at the outer edges of the solar system.
I think it's natural that this telescope should always be known as the Pluto telescope. What Clyde was doing was to take 2 photographs of the same area of the sky, separated by a night or 2, and then compare them.
Clyde's job was to use a machine called a blink comparator. He would take 2 images of the night sky, taken several days apart. If anything moved on the plates, it might just be the planet he was looking for. Over the course of 10 long months, Clyde searched the skies, scanning thousands of images. But finally, on the 18th of February 1930, he saw a small and moving speck of light.
I looked in there and I spied it almost immediately, and a tremendous thrill came over me and I almost shook. And I realized I had some big game.
Clyde's discovery was quickly named Pluto and designated a planet for the next few decades at least. Sadly, Clyde passed away before New Horizons launched, but soon, here at Mission Control, the world would finally get to see in glorious detail that faint speck of light that he first saw over 85 years ago. It's 11 p.m. on Monday night, and somewhere up there, New Horizons is 400,000 kilometers or so from the surface of Pluto, only a little bit further than the Moon is from the Earth. And in Mission Control behind me, New Horizons team will be going through the data that's just been received from the probe, its last message to Earth before it encounters the Pluto system. It's an incredibly exciting time, but the probe won't be sending data back to Earth in real time. It's going to be too busy doing science, pointing its cameras and its instruments at Pluto, at Charon, and at the other moons in the system, and won't turn its antenna to talk to Earth until tomorrow evening. So we have to endure this most exciting day in silence. I can't imagine what they'd be feeling right now. They're scientists, so they believe in the models that they have that tell them that New Horizons will be safe. They're engineers, and they believe that their little spacecraft will succeed just as it's traveled across the solar system. But they're also people. And if I'm this nervous right now, I can't imagine what they're thinking.
The risk to New Horizons was massive. It was travelling so fast, at 32,000 miles an hour, even a speck of dust could destroy the entire probe. And it had to navigate a hazardous path through the system of Pluto and its 5 moons. It would need to intersect with Pluto's orbit at precisely the right point to pass inside the orbit of Charon, just 8,000 miles from the surface of Pluto. And while it was making its flyby, it would be pointing all its sensors at Pluto. We would not be able to make any contact with it from Earth.
Meanwhile, back on Earth, at the precise moment that New Horizons was making its closest approach, we all gathered with the scientists and with the media. To mark the event, the mission controllers released the final picture that the spacecraft had sent back the night before. This would be the best view of the whole planet that we had ever seen.
Ladies and gentlemen, Pluto has never seen before.
Look at that, it's amazing. It's much more varied than I thought it was going to be. I thought it would be a simple world for some reason.
So small, simple.
Exactly, but it's not like that at all. What I want to know is whether this is a basin. You can imagine this is a giant crater that's filled up with snow.
There's always these strong dark areas.
Yeah, and then over here, that could be an impact crater.
But it looks as if it's got craters within it.
That's right, so it might be old. So I'm seeing craters and snow and...
So, to me, this is the precursor. It's sort of whetting our appetite for the sort of the really detailed images to come.
Yeah.
This incredible view revealed an intriguing new feature. A bright white heart. What could it be made of? A different sort of ice? Or snow? Or was it some strange surface feature? They were already calling it the Tomball region. I wanted to get a sense of how much it meant to a very special person, Clyde Tomball's daughter, Annette. Now he's actually gone out there and gone to visit Pluto. How do you think he'd feel about that?
Oh boy, would he like it. He'd have a lot more to do.
Yeah, which is wonderful.
Right.
And now they're looking to name sort of major features after him.
Yes, and the heart is named after him.
Yes.
And that is a great honor because he loved astronomy, and how better to express your love in astronomy than have a heart named after you.
On the center of the planet.
Yes, right, the main feature.
What that feature was made of had everyone guessing. But some more clues came when the colour data from the Ralph instrument was added to the picture. I have to show you this. We've got this amazing coloured image of Pluto and Charon. The only problem is I don't understand what the colours mean. I'm going to go and find Carly Howard. Where are we? We're about 3:30 on Tuesday. Right, how are people feeling?
I've had an hour's sleep since 5 a.m. yesterday. I mean, last night, it was 1 a.m., the full-frame Lorry image comes down. So there's only 5 of us in the whole world that had seen this image of Pluto. And we're all just sitting there at that moment of like, oh, whoa. And today, the President of the United States retweeted that image. Like, so it's gone from 5 people in one room to the whole world seeing it. And just to see that ramp up it's been an exciting ride.
We've got to talk about the colours, because that's the point of these images. And when you look at Pluto, it does look very different in this image. The heart seems to have been cut in half, for starters.
I know, it seems to have been broken. Yeah, and that's telling us a lot of things. So colour, we know just from our daily experience that it's very diagnostic of composition. Grass is green, concrete is brown. And so just to a first look, anything that's different colours is going to be made of something that's slightly different. Now, what that exactly means needs a lot more work. Things that tend to be brighter and newer, things that are red tend to be more sort of hydrocarbony. And then the blue stuff, maybe we've got a bit of methane ice or something else. I guess I can use methane ice.
Methane ice, yes,
yeah.
because you're talking to Brits.
That's right, very exciting.
So the heart being broken in two, I know people have said that on the right-hand side, the bit that's missing in this image, we've seen a few more craters. So could that be older surface?
Craters do indicate usually an older surface. So if we think about the Earth and Moon, the Earth and Moon have probably been hit by the same amount of stuff. So where places don't have craters, that means they're new. And that's a really great diagnostic tool. It could be that it's just been covered over. We do see movement of volatiles. We're expecting to see that on Pluto. So it could be that the surface underneath this is actually really old, but there's something's kind of covering that surface. And that's something that we'll just need more time to look into.
So we'll catch up with you a bit later. Thank you so much. Keep the caffeine coming. Carly and the rest of the team will be analysing the composition of the bright ices in the heart over the coming days and months to find out what they're made of and what structures they might be forming. But what about the rich red colour seen across the rest of Pluto? Rather than ice, scientists were suggesting that it might be a thin coating, initially created in its cold nitrogen and methane atmosphere. Here in Baltimore, there's a team investigating how this could be happening. In this laboratory at Johns Hopkins University, they're studying the chemistry of planetary atmospheres. And something very exciting happens when you mix nitrogen with methane and the ultraviolet light that comes from the sun.
So this is a planetary atmosphere simulation experiment. So we have a chamber that we can fill with whatever gas mixture we want. So usually we'll start with something like nitrogen and methane, and then we expose them to an energy source. And the subsequent chemistry often results in particle formation. And in this case, for planetary atmospheres, we call these types of particles tholin. And tholin is generally red or brown or yellow, depending on what recipe you've used.
How would you connect what this experiment's doing to what we've seen from New Horizons over the last few days?
So Pluto itself is actually quite red, if you've noticed in the images. For now, it's just speculation based on the fact that we know the building blocks of tholin exist in the atmosphere of Pluto. And then we also know that the material that we see is red.
Chemistry like that being done here, along with the data being collected by New Horizons, is helping to reveal what exactly is colouring the surface of Pluto 3 billion miles away.
This was made with a different gas mixture, and you can see that the colour is slightly different.
Oh yeah.
Even just with these two, which were made with methane and nitrogen.
These particles of complex hydrocarbons may not look like much, but it's incredible to think that we might be making a little bit of the dust of Pluto right here on Earth.
Back at Mission Control, the other surprise was that the red material from Pluto's atmosphere also appeared to be forming on the North Pole of Charon, which otherwise looked to be a fairly uniform grey. It was a discovery that was already proving a source of interest and speculation to mission scientists like John Spencer.
No sleep, but lots of excitement.
Oh yeah, it's enough excitement to keep me awake. That image is just mind-blowing, and it's really now giving us something to chew on.
So I hear you're theorising on the fly about that dark patch on Charon.
There's an idea that I think actually might be the truth, that that dark stuff is actually a staining from Pluto. It's Pluto's atmosphere escaping from Pluto and then condensing on the winter polar region on Charon, where it gets incredibly cold, probably just a few tens of degrees above absolute zero. And then while the frost is sitting on the surface, it gets cooked up by ultraviolet light and cosmic rays into this brown gunk that we think we form from the methane, which doesn't evaporate when the sun comes back. So just over billions of years, you can build up that brown deposit there. So Pluto is staining the poles of Charon, which is kind of amazing to think about.
New Horizons was changing our view of Pluto and Charon even before we knew if it had survived its hazardous journey past them. As we gathered on Tuesday evening, no one had heard from the spacecraft for 24 hours. And we were all anxious to hear it make contact again.
Now that signal is going to be collected by the Deep Space Network. This is a network of dishes across the world ready to receive signals like this. And they're connected to Dawn, Cassini. All these spacecraft are connected to the Deep Space Network. Now, we're sending a signal up at the moment, but we're waiting for that signal to come down. The signal to confirm that everything's okay with the spacecraft.
Stand by for telemetry.
This is good.
For Alice Bowman, it had been a 10-year wait.
Okay, copy that. We're in lock with telemetry with the spacecraft.
I told you it would be fine. I wasn't worried. These people weren't worried.
I was worried. This is such a culmination of so much work.
They look stunned in Mission Control. Look at this.
Go ahead, CNDH.
CNDH reports nominal status. Our SSR pointers are where we expect them to be, which means we have recorded the expected amount of data.
Copy that. Looks like we have a good data report.
That's full data. They've got everything they thought they would get.
So the spacecraft has been flying through, looking the wrong way, getting as much data as possible. It's now turned around and said, everything's okay. I've got the data. I'm going on.
We have a healthy spacecraft. We've recorded data of the Pluto system, and we're outbound for Pluto.
And now they let Alan Stern into the control room. That's a full scorecard for New Horizons.
They'd travelled 3 billion miles and hit a target that was only 60 by 90 miles. That's the equivalent of throwing something across the Atlantic Ocean and it landing in my hand. The excitement and the relief were palpable.
Thank you.
How do you feel?
There are words, I'm so excited.
Nominal does not cover it.
It's not so much relief, it's just that, wow, it's real. We've got a spacecraft full of fabulous stuff, and now we're going to get all our goodies that we've been waiting for so long.
Now the real science begins, and I'm just thrilled for everybody.
But we would have to wait another day for New Horizons to have time to send us the data that it was still busy collecting. Data which was bound to spark new discoveries and plenty of debate. But there's one debate that will not die, the one that started when we astronomers demoted Pluto from planet to dwarf planet. And we asked public astronomer Marit Kukula to give us the lowdown on Pluto's planethood.
It's proven to be one of the most divisive issues in modern science. In one stroke, thousands of textbooks were out of date. In my role as public astronomer here in Greenwich, I'm always being asked about Pluto. Why was it reclassified? And if it's not a planet anymore, then what on earth can it be? Right from its discovery, Pluto seemed different from the other planets. Here at the Royal Observatory we have records going back for hundreds of years, and somewhere we should have a record of the discovery of Pluto. 1917, that's too early. 1987, much too late. Clyde Tombaugh had been set the specific task of finding a planet. So when he saw his moving point of light in 1930, what else was he going to think he'd found? Here we have the President, Council and Fellows of the Royal Astronomical Society sending the Lowell Observatory their heartiest congratulations on the great discovery of the trans-Neptunian planet. But trouble was brewing from the word go. Within weeks, Pluto's status was being called into question. Its eccentric orbit and small mass set it apart from the other planets. More importantly, some scientists argued that Pluto might not be alone. Over the decades, our ideas about the formation of the solar system developed. It was suggested that the edge of the dust and gas cloud from which our planets formed would have been too spread out to condense into planets. Instead, there could be something very different. Scientists reasoned that there could be hundreds of thousands of icy objects on the edge of the solar system that had failed to be incorporated into one of the major planets. They called this region the Kuiper Belt, and Pluto's status as a planet started to be called into question. On the 5th of January 2005 came the fatal blow. Scientists in California discovered another small moving point of light. This was Eris, a world they believed was bigger than Pluto. This was huge news. The likelihood was there could be many more large objects out there. Scientists were faced with a choice. Either open the doors to potentially hundreds of new planets, or Pluto was for the chop. In 2006, the International Astronomical Union put it to the vote, and it wasn't good news for Pluto. The IAU decided that a planet had to be an object in orbit around the Sun that was massive enough for gravity to squeeze it into a spherical shape, but also it had to be gravitationally dominant, and that meant it must have cleared its surrounding region of other similarly sized objects. But with everything else out there in the Kuiper Belt, this was Pluto's downfall. So where did this leave Pluto? The IAU decided to classify it as a dwarf planet. To many, this was seen as a demotion, but I'm not so sure. As a planet, it was the last gasp on the edge of the solar system, but now it's an exciting example of a brand new class of objects. Whatever we learn from it will change the way we think about our corner of the galaxy.
Back in Maryland, the wait for the first data was nearly over, and we were finally going to see the first high-resolution images of Pluto's surface.
It's 3 o'clock now on Wednesday, and we're just going to start the press briefing. Here they're going to show us the first close-up images. I'm really interested in the moons, what detail we've got on those.
The moons, I'm sure they're interesting, but Pluto is going to be incredible. We're going to get our first very close-up images, and I think they're targeted on the edge of the heart, one of the most interesting regions we saw yesterday.
Well, I had a pretty good day yesterday. How about you? John Spencer is going to tell us about just the first frame of that mosaic that's already down on the ground, and which has already given us a big surprise. John?
Thank you, Alan. So we're zooming in on this area. Here's the image. Here it comes.
So the press conference is still going on, but I had to show you this. This is the first high-resolution image of the surface of Pluto, and it shows mountains. There are mountains in the Kuiper Belt, about as high as a decent-sized rocky mountain, and made, they think, of what they're calling bedrock, but what is actually water ice.
Moving on to Sharon, the beautiful Sharon.
It did. It was wonderful.
It is. All sorts of information coming out. So we've got one high-resolution image of the complete moon. A dark area in the north, which they call Mordor. And the surface is riven with a long line of cliffs and ravines along its equator, and a huge canyon on its eastern edge.
I think what's really fascinating, this is 1 day's download. There's 16 months worth of data to come down. We're going to learn a ridiculous amount from these images. Right, let's get back in.
Yes.
Everyone had hoped for something surprising, but no one expected terrain like that, especially not mountains. I made a beeline for mission lead Alan Stern to get his first reaction. Hey, congratulations.
Thanks very much.
Yeah, can you tell us about the mountains? It's just incredible. Everyone's getting excited about skiing on Pluto and so on, but what do they mean to you?
Well, it's just mind-blowing to think that there's a range as tall as the Rockies, the size of western Colorado. And if you look closely, and these images are being released, we can even see what we think are frosting on the top of them. That's snow caps on mountains, right?
Nice. Picture perfect.
Yeah, and it probably comes from recent seasonal cycles in the last orbit, for example, where nitrogen from the atmosphere precipitated out, made of snow. Lower down, it seems to be darker material. Higher up, brighter material, just like you'd find on the Earth.
Good stuff. Well, enjoy.
Thanks.
Congratulations.
Okay.
We'll see you again. Cheers.
Yeah.
These snow-capped mountains at the bottom left-hand side of Pluto's heart are a truly incredible discovery. Giant mountains like these only occur on bodies that have been geologically active. And everyone had assumed that this tiny, icy world was dead. So what could be driving that process? To work out what's going on, I need a scientist, and I'm betting that at this point, the best way to catch one is with coffee. Luckily, Carly Howitt is just as susceptible to the lure of caffeine as I am.
So you have to remember that the surface isn't rock, this is water ice mountains.
Which sounds crazy.
That's crazy, right? Like we don't, water ice in the Earth just wouldn't be strong enough to sustain that sort of structure. But what you're looking at on Pluto are temperatures, surface temperatures that are so cold that water ice almost has a sort of rock-like quality of it. It's just absolutely solid. And so it's able to support these massive structures. And just seeing those and seeing the shadows that they cast, these huge shadows across the surface, was a big surprise. We definitely weren't expecting.
It's
that.
the shadows that give you the height, right?
Absolutely. We know where the sun's coming from, and so you can look at where the shadow falls and tell yourself how big they are. I mean, it's much like standing outside on a summer's day. Your shadow only extends so far. And so if you understand the geometry, you can guess how high they are just based on their shadow.
I don't remember anyone predicting mountains. Do we understand how these things could have grown?
I have no idea how those mountains could be formed. Pluto has quite low gravity. It's a small body. I mean, we don't get like winds and water like you do on the Earth. So how you get uplift, how does that even happen? I don't know.
Something coming from underneath, presumably, but then...
But how? I mean, it's not like you're going to get uplift like in the Himalayas. I mean, this is... I don't know. And I look forward to figuring it out with everyone else and finding out.
The other thing that's astonishing about this image is that there are no visible impact craters. Everyone was expecting Pluto to be covered in craters, like our moon. Somehow, Pluto's surface has been reformed, suggesting volcanic or tectonic activity.
We'd expect it to just be geologically dead. We know it's been bombarded a lot over its lifetime, and so you'd expect its surface to look like the moon, just heavily cratered, but it's not. So what does that mean? And this is what we're all sort of scratching our heads about. To be able to see that much of the surface and not see a crater is very surprising indeed.
How do we distinguish volcanic activity or tectonic activity from it having snowed yesterday? Could that just be snow that's covering an old landscape?
It could be, but we think we'd see traces of that in the same way that when your garden's covered in snow, you can still make out that it's your garden. You sort of expect to see hints of craters in that, and it really does look very, very flat.
So what's causing this geological activity? On Earth, mountains and new lands are created by plate tectonics. This itself is driven by heat created by the decay of radioactive elements in the planet's core. But most of the other icy and rocky worlds in our solar system are so small they were presumed to have exhausted their supply of radioactive elements long ago. Even the once active Mars is now dead and cold. There are moons of Jupiter, Saturn and Neptune whose surfaces show signs of current activity. The fresh icy surface of Europa and Triton, or the stunning ice fountains of Enceladus. It has always been thought that these processes are powered by heat generated by the constant gravitational squeezing and stretching caused by their giant host planets. But that can't be the case for Pluto. So if it's hot on the inside, where is the heat coming from? I went to find John Spencer to see if he had any ideas.
Rock contains radioactive elements, and the Earth being large and mostly rock contains a lot of those elements, and that's what powers most of the geology of the Earth, is the heat from that radioactive decay. Oh. Because these objects are so much smaller and they're only about half rock, not completely rock, that's a much smaller amount of heat, but it might still be enough to process their surfaces.
But it's not just Pluto that's causing us to rethink some of our ideas about the solar system. We have a rather glorious image of Sharon.
Yes.
And I mean, this is spectacular.
Yeah, this was a big surprise when this image came down. We see a belt of fractures running across the disk of Sharon. Then on the edge of the disk, we can actually look right down the length of a canyon.
Ah, yes, yes.
So we can measure it. We can measure its height just because we can see sky through the other side of it, which is pretty amazing. And this is deeper than the Grand Canyon.
Wow.
This would be a spectacular thing to stand on the edge of.
And like Pluto, large parts of Sharon are remarkably crater-free. It all suggests some unknown geological process.
We see a world with craters, but there is a lot of space between those craters. So something is covering up craters.
Oh, I see. So it's been bombarded, but then the surface has been removed.
And we have no idea what that process is yet.
But Pluto and Sharon share more than geological activity. Sharon's dark stain, Mordor, backs up John's ideas that they're sharing an atmosphere and both creating those dark red tholins.
Pluto and Sharon are close enough together that they really can have an effect on each other. As gas is escaping from Pluto, as it's doing all the time, some of that will get temporarily caught into Sharon's sphere of influence, but if it gets bombarded and converted into other hydrocarbons that are kind of sticky and don't evaporate off,
yes.
They will stick to the surface.
Lovely, and build up over the years.
Right, and each season you might only get a few molecules, but over billions of years, you could actually build up enough to discolour the surface.
Together, the shared geological activity and atmosphere lend weight to the idea that Sharon is so closely entwined with Pluto that it's far more than just a moon. It's an idea I've been investigating. It's an issue of mass, or I should be more precise and say relative mass. Sharon is huge compared with Pluto. It has 1/8 of the mass of the dwarf planet. And that's so huge that it stretches our definition of a moon. Can a moon have 50% of the mass of its host? 90%? Just how big can a moon be? For comparison, we can look at the moon with the second largest relative size, and it's a bit closer to home. Our moon is 1.2% the mass of the Earth. That might not sound like much. It's only 1/10 of Charon's relative mass. But it's the biggest ratio of all the other major planets. It's certainly big enough for its gravity to have a real impact down here. And the tides are just the most visible consequence. There's a less obvious effect of our large natural satellite, and it perhaps is more surprising. It turns out that the moon doesn't actually orbit the center of our planet. In fact, far from it. We know that the Earth exerts a gravitational force on the moon, and that's what keeps it orbiting about it. But the moon is actually big enough to have a substantial pull on the Earth itself. So rather than thinking of a static Earth with a moon orbiting around it, what we should be thinking of is the Earth and the moon orbiting about a common centre of mass. And that point is known as the barycenter. For the Earth, the barycenter, this centre of rotation, sits 1,000 miles below the planet's surface, about a quarter of the way towards the core. Crucially though, it does sit within the body of the Earth. So our moon is definitely just that, a moon. However, when it comes to Charon and Pluto, things are a little different. Charon's relative size means that the barycenter, the system's centre of mass, doesn't actually sit within Pluto. Instead, the two bodies orbit a common point above Pluto's surface. In a very real way, Charon doesn't actually orbit Pluto. The fact that the system's barycenter sits between the two objects leads many scientists to conclude that Charon shouldn't be considered a moon at all. Instead, the two should be considered as a binary pair. In this case, binary dwarf planets. So why does this matter? Well, initially, we thought that binary systems were pretty rare. None of the major planets fit the criteria. But scientists are beginning to realise that the Kuiper Belt may be full of them. As many as 10% of the objects seen display the characteristic wobble associated with binaries. This has actually been something of a surprise. To produce binaries, it's thought you need a large number of objects close together. It's only then that you have enough collisions and gravitational encounters for the binaries to form. But with current models, the Kuiper Belt just doesn't seem dense enough. There are lots of objects, but they are spread over a vast area of space. So just how did all these binary systems form? The truth is, we don't know yet. But by studying Pluto and Charon, we may just unlock one of the great mysteries of the Kuiper Belt.
According to our current models of solar system formation, Charon was born when something smashed into Pluto. And until this week, everyone believed that this moon-making impact happened in the very distant past. But maybe the unexplained geological activity that we now see evidence for on both Pluto and Charon could be explained by a relatively recent impact. That would make Charon one of the solar system's youngest objects, another piece of history that New Horizons is calling into question. Our understanding of Pluto was changing incredibly fast, but one of the big mysteries was still unanswered. What exactly is that giant icy heart so obvious in the images from Pluto?
Following the July 14th.
On Friday, NASA revealed its most surprising image yet, saving the best till last. A new picture from right next to the mountains, yet it looks completely different, showing a strange, craterless terrain, covered with mysterious polygons and odd hills. The team are calling it Sputnik Planum.
And then,
For the mission's principal geologist, Jeff Moore, this could be the most convincing evidence yet that Pluto is an active world.
You see, these, 15-mile, 20-mile wide polygons, which they are themselves bounded by few mile wide troughs around their edges. Some of the shallow troughs have dark stuff in them, but elsewhere we see clumps of elongate hills which are following the trough. So somehow there's something that forms actual hills that stick out of the troughs and make basically little walls around some places of some of the polygons.
We see polygons like these on Earth and on Mars, where ice warms and cracks in the sun. But Jeff has another theory, that the polygons reflect what's happening beneath them.
So the alternative explanation for very large polygons is that they're formed by convection. Convection is something that anybody, making a pot of porridge can look down into the porridge and see the blobs of porridge rising and falling.
Well, what would be convecting? I mean, Pluto's cold, we'd think it would be solid.
Yes, that's a good question, isn't it? So we're not quite sure what the material is that makes up Sputnik Planum. But it's probably one of the exotic ices or some combination of the exotic ices. They have mechanical strength of silly putty. So even though Pluto doesn't produce a lot of internal heat, it is, more than half of its interior is composed of rock, and rock has radioactive elements. So there is modest internal heating from below, and maybe these really soft exotic ices only need to have like a 1 or 2 degree variation and temperature to cause the ice to slowly convect, at least in that location. And of course, most importantly, there's the complete absence of craters. And the absence of craters is mind-blowing because that means that the surface has to be very young and maybe an ongoing process.
And young in this case is what?
It's probably not older than, and this is just a very, very hand-wavy number of 100 million years. And but again, that's the kind of strange thing about no craters is that it might also be like a week old too.
Yeah.
Whatever it is, something's going on that either it's either formed since it's too short a time for craters to form, or something's modifying the surface faster than the craters can populate the surface. One of those two things has to be happening.
I don't think there's anything more exciting than a confused scientist.
Absolutely. In fact, it's nothing more exciting to be than a confused scientist.
No one yet knows how or why Pluto's so active, but the team will spend months poring over the New Horizons data as it streams down to Earth in order to find out.
The press conference wasn't just scientists and journalists. There was also a sprinkling of more familiar faces.
So, Brian.
So, Dr. Linton.
It's nice to have another Sky at Night veteran here.
A little event of our own here. Yeah.
What do you make of it?
It's amazing, amazing. It's boyhood dreams time, isn't it? Patrick would love it, wouldn't he?
He would. He would have been in the front row shouting questions.
Absolutely, yeah. Amazing, yeah, because we all knew about this 9th planet when we were kids, and it was a tiny white speck, and that's all we knew.
Yeah.
The beauty of it. I mean, I'm knocked out.
Well, nice to see you. I'll let you go and do your report on science. But, see you later.
The variety of Pluto's terrains, with its mountains and plains, is incredibly exciting. But you don't necessarily need a NASA mission to see Pluto for yourself. With today's amateur equipment, it's easy to discover the wonders of the solar system and out into the galaxy beyond. You can even detect and photograph faint, magical Pluto in the same way that Clyde Tombaugh did 85 years ago. Pete has the details.
It's probably fair to say that Pluto isn't the easiest target to find in the sky. As well as being relatively faint, you probably need a 10 or 12-inch telescope to actually see it at all. It's currently in the constellation of Sagittarius, and that means to locate it, you need to point your telescope right into the heart of the Milky Way galaxy. But while Pluto's a challenge to pick out against the thousands of background stars, it's also a great opportunity to see some of the other wonders that lie nearby. Now, this magical part of the Milky Way is quite low down and close to the horizon, so it pays to have a good friend like Ian who's got a field with a good low southern aspect. And as we're doing this in the middle of summer, then the sky doesn't really get dark until about midnight. Now, we've got some clouds up there at the moment, but what do you reckon, Ian? Do you think the clouds are going to clear by midnight?
Well, I'm still hopeful, Pete. It did clear earlier, and I think it will again.
I admire your optimism. Ian's faith is rewarded. And it's not long before stars begin to appear. Now we can begin our search for Pluto. The key is to look for the teapot,
This isn't actually a constellation, it's what's called an asterism, an unofficial pattern of stars useful for navigating the night sky.
The centre of the Milky Way galaxy lies just to the right of the spout of the teapot. And if you can imagine where the steam would be rising out of the spout, then here there are some really beautiful deep sky objects. So before we go off hunting for Pluto, let's have a look at some of these.
Due north of the teapot, to the west of a constellation called Scutum, you'll find M16 and M17. M16 is the Eagle Nebula. This was the subject for Hubble's famous Pillars of Creation image. And M17 is the Swan Nebula. This is one of the brightest star-forming regions in the galaxy. But there are plenty of other objects to look at too.
Come and have a look at this.
What's that? Oh, wow.
Yeah.
So that's M8 and M20?
Indeed, in the same shot.
Ian's captured the Lagoon Nebula and the Trifid Nebula. No mean feat given how south these objects are.
That's something you don't see very often from the UK, isn't it?
Yeah, I just get that down.
Pluto may be closer, but because it's much fainter, it's trickier to find. Northeast, or above and left of the teapot, is a spoon-shaped asterism, predictably called the teaspoon. Pluto is currently very close to the edge of the teaspoon's bowl, furthest from the handle. Full details can be found on the Sky at Night website.
Now we know Pluto's there, but unless we had a big telescope and really detailed charts, it's a difficult thing to pick out visually. So we're going to try and track it down taking photographs. Now I've got a fairly inexpensive DSLR camera here, and it's set up with my favourite wide field telescope, which has got an aperture of 130mm and it's f3.3. But you don't need to use a telescope, you can use a normal camera lens. Anything like a 200mm or longer focal length should be ideal for the task.
The idea is to take several photographs of the same patch of sky with a period of time between each one.
Now, if you've got a big telescope with a close-up view, then just a few hours between shots should be enough. But if you've got a wide field setup, then you need at least a day between your shots to show any movement.
Once you've got all your shots, you can load them into a computer. There are plenty of software options to help you align the stars. The aim is to create a video sequence of your images.
So what you're looking for is a point of light which moves between each frame. Now here I've got 3 images which I took over the course of 11 days, and if you look really closely you can just about make out the progress of a faint speck of light, and that is Pluto. And it's quite amazing to be able to see an object that until 85 years ago people didn't even realise existed.
Ladies and gentlemen, Pluto is never seen before.
We've had a ringside seat for one of the great missions of modern space exploration. And for the scientific team, and for the rest of the world, Pluto is now far more than Clyde Tombaugh's little speck of light.
In the space of just a few weeks, Pluto went from the hardest thing in the solar system, practically the hardest thing to study, to one of the easiest, right? And it's just going to keep getting easier and easier.
The New Horizons probe is a feat of engineering that has given us a picture of the Pluto system far more exciting and interesting than we dared hope. Pluto and its sister Charon are rich and varied worlds.
And it just blows my mind to think, well, instead of solid rock, these things are solid ice. And so it's a very different place. It's a very different place to what we're used to.
On Pluto, imposing mountain ranges of solid water ice march across the surface. Vast swathes of land are covered in coloured hydrocarbons, or they're blanketed with rippling beds of exotic ice. And on Charon, massive geological forms dominate the landscape.
All of these features point to geological activity that cannot easily be explained, and in time may force us to rethink our ideas about the solar system.
It's really now giving us something to chew on and starting to understand Pluto instead of just, what the heck is this? Now we can really start to see what's going on.
Well, we said that Pluto wouldn't disappoint, but New Horizons delivered beyond our wildest dreams. and it's not done yet. It's heading out into the Kuiper Belt, a region of space teeming with thousands of small objects. And who knows, maybe there are still greater surprises ahead than any that we had at Pluto.
The Kuiper Belt is interesting because it's a region beyond where the big planets formed. So it's really a pretty pristine remnant of the conditions when the solar system was forming that we really don't get anywhere else in the solar system.
The chance to use New Horizons to get more data on other objects was far too good to miss out on. But finding an object on its set flight path wasn't straightforward.
The amount of fuel only allows us to turn the spacecraft by about ½ degree from its course. So that gives us access to just a very narrow region out in the direction we're already going.
Running out of time, John and the team turned to the most famous telescope of them all, Hubble. With no atmosphere to look through, the Space Telescope soon spotted one of these remote chunks of icy rock.
This is a composite of 5 images. They were taken over the course of one orbit of the Hubble telescope about every 10 minutes. And we see here the motion of the Kuiper Belt object, pretty regular motion in a straight line against the background of these stars here.
The object appeared to be between 20 and 50 kilometers across, about 1% of the size of Pluto. But unlike the dwarf planet, it's likely not massive enough to form into a sphere. It's hoped its structure will have been unchanged for billions of years.
When I first started in astronomy, we didn't even know there was a Kuiper Belt. It was just a theoretical notion that there might be objects other than Pluto out beyond Neptune. Now we get to go there and see it up close, and it's just remarkable that we can do this.
As the sun sets on a week of remarkable discoveries, we're beginning to get a sense of what it's really like on Pluto. And it's transforming our ideas about the outer solar system.
What a week it's been. But to me, this marks a real milestone in the exploration of space. And of course, New Horizons will continue sending data back over the coming months and continue to expand our knowledge.
It's the end of a long day here at Mission Control, and the light is about the same as it would be at noon on Pluto. So wherever you are, go out just after sunset, look up and enjoy this Pluto time, and imagine standing in the shadow of a giant icy mountain revealed to us by a plucky little spacecraft sent all the way from Earth.
So no matter what part of the solar system you're in, get outside and get looking up.
Good night.
And if you want to revisit previous planetary flybys, including Jupiter, Uranus and Saturn, take a look at our collection of Sky at Night programmes from the archive. Go to bbc.co.uk/skyatnight and follow the links.
Still to come here on BBC 4, mind-boggling mapping as scientists try to discover just how big the universe is. Stay with us for Horizon next.
We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
It's been almost a decade since New Horizons rocketed out of our atmosphere. For the team who built it, years of work were now hurtling towards Pluto, a 3 billion mile journey away. Heading out beyond Mars and through the asteroid belt, in 2007 New Horizons passed Jupiter. It was using the gas giant as a gravitational slingshot, increasing its speed and cutting 3 years from its journey time. But for Mission Operations Manager Alice Bowman, it offered a perfect test for her spacecraft.
Jupiter was extremely important for the mission. All of our instruments were brand new to space, and so we were using Jupiter as really an opportunity to test out these instruments for really the first time in observing a real object.
While it was passing, the spacecraft trained its cameras on the moon Io.
We were at the right place at the right time. We got notice from the Hubble Space Telescope that they had detected something going on.
This snapshot is from the colour imager Ralph. It's undeniably beautiful. But it's the black and white lorry camera that captured the real detail. The camera caught a huge eruption, 200 miles high, coming from the volcano Tavashta.
To see those images come back, all that hard work, all those long nights, come back with the spectacular images, it was great.
8 years ago, the spacecraft left the Jupiter system behind, crossing the orbits of Saturn, Uranus, and Neptune. It was now hurtling through the void towards Pluto, an object that's always been a bit of a mystery to us.
Before New Horizons formed our understanding of the solar system, throwing up into the air our ideas of what causes changes to planetary surfaces. How can such a tiny world have such incredibly varied terrain, of mountains and plains? What are the different patches of colour across its surface? And do we need to rethink its relationship with its huge moon, Charon?
We'll also be showing you how to find Pluto in the night sky for yourself, examining why some no longer consider it a planet, and looking at where New Horizons is headed next. It all began last Monday, here at the Applied Physics Laboratory in Maryland. With just 24 hours to go before New Horizons reached Pluto, the flight controllers were in lockdown, while they nervously kept track of their spacecraft.
Copy that, RF nominal.
Outside, the world's media was gathering to see the revelations that New Horizons would make.
The first scientific details were already emerging. While the spacecraft was still millions of kilometers away, it has started sending back increasingly rich pictures. And now scientists like Carly Howitt, one of the core members of the imaging team, were nervously waiting to see what other surprises would emerge. When you get the first images after the flyby, what's the first thing that you look for on the surface?
Anything that's indicating that Pluto is still active. After that, it's going to be just what's going on, like how's the color changing, how cratered is it, and so those are going to be things that I'm really excited to see. I got married last year, and it feels like the same thing, like you've done all this planning, and all of a sudden the days here kind of make sure you remember each and every moment rather than just it all being a whirlwind.
Let's hope we see some of those things.
Yes,
we will.
Good
luck.
Thanks very much.
Yes.
For Carly, and many here, like Mission Controller Alice Bowman, this week was a critical moment after decades of preparation. A very long journey that has taken us right across the solar system.
Came along, we had to figure out everything about Pluto from a distance of 3 billion miles, and this is the best image that we had. And trying to find detail here is like trying to make out the writing on this coin from 13 miles away. This blurry, grainy image is what Pluto looks like to the Hubble Space Telescope, and we've had to put up with it. Despite the likes of the Voyager probes touring the solar system, Pluto has just never been in the right place for them to visit. Before its encounter with the dwarf planet, I caught up with Alan Stern, the principal investigator for the New Horizons mission. For him, the flyby is the culmination of decades of work.
This mission is running the anchor leg in a 50-year sequence of missions in which the United States has explored the entire solar system, from the closest planets, Venus and Mars, all the way out now to the farthest frontier.
So seen from here, from Earth, Pluto's just a speck, but what do we know about it already?
With Earth-based techniques and the Hubble Space Telescope, we've been able to learn a bit. So we know it's a fascinating world. It's a planet with 5 satellites, it has an atmosphere, it has seasons, we've discovered a polar cap, there are big surface markings.
Scientists were able to combine multiple Hubble observations to produce our first maps of Pluto. They revealed a world with dark and with light patches, a first hint of the surprises that awaited on Pluto's surface. We also suspected that the surface would be unlike anything we'd seen before, with temperatures as low as minus 233 degrees Celsius.
We know that the surface is primarily made of nitrogen ice, snows of nitrogen. We don't know how deep they are, but we also know that there's carbon monoxide snow, that there's methane snow, and there may be vast expanses of water ice as well.
But nobody knew how those strange snows and ices are distributed across the surface. What's
3, 2,
The revelations about New Horizons' visit to Pluto last week made headline news.
Scientists have tonight been celebrating the arrival of detailed images of Pluto.
Here at the Sky at Night, we've been lucky enough to be behind the scenes, following the unfolding story every step of the way.
We've recorded data of the Pluto system, and we're outbound for Pluto.
Revealing the in-depth science behind the incredible images of Pluto and the surprising discoveries of mountains and strange geometry on the surface of this cold and distant world.
It's a fittingly stunning mission for our 750th episode. This is Mission Control at the Johns Hopkins University. For the past week, the world has been amazed by fabulous images of Pluto, beamed back from across the solar system.
It has been an astonishing week. When we got here, some people feared that Pluto would turn out to be a frozen and dead world, but we've watched as it turned into anything but. Until recently, Pluto was just an indistinct speck of light at the far edge of the solar system. As recently as April this year, this was our best image of Pluto and its moon Charon. But now, New Horizons has changed all of that.
This week's findings have
structures or surface features might they form? And what, if anything, could be going on inside this icy world? So if you could discover anything, if you could order anything from Pluto, what would you choose?
I would order something wonderful, something that we don't expect. You know, that's been the history of planetary exploration. The first mission to Mars found craters, and then they found river valleys, and no one expected either. And the first missions to the giant planets, to Jupiter, found volcanoes on Io and an ocean at Europa. And it's been our history in planetary exploration that we typically find completely unexpected richness in nature. And I'm hoping that Pluto presents us with something similarly wonderful that we're all talking about after the encounter.
While we were waiting for New Horizons to cross the final few 100,000 miles to Pluto, I went to investigate the suite of instruments the spacecraft was carrying. If you're going to send a spacecraft 3 billion miles into space, what sort of spacecraft do you build? Well, this is a 1/4 scale model of the New Horizons spacecraft. So the size has been described as about a baby grand piano, and you can see that from the shape here. How do you power such a spacecraft? Well, you're so far away from the sun, you can't use solar panels. There's not enough sunlight reaching them. So instead they use this. This is a nuclear device. It contains plutonium oxide. As the plutonium dioxide decays, it produces enough heat to generate 200 watts of electricity. This powers and heats the spacecraft instruments. While the temperature outside is below -200 degrees Celsius, the inside of the craft sits comfortably at room temperature. Down here, we've got a very important instrument. This is LORRI. It's the navigation and high-resolution camera. The wonderful images we've seen on the approach to Pluto have all been taken by LORRI. But LORRI is a black and white camera. Extra color information is provided by Ralph, that images in the visible and the infrared. The other instruments include ALICE,